Show that the slope of a line is invariant under the translation of x's. Okay, let us begin. So here in this problem, what we'll do, we're going to consider an equation of a straight line in some coordinate system. Now we're going to consider the general equation of a line ax plus by plus c equals to 0. We're going to label this as number 1. Now what we'll do, we're going to keep the second term as it is, by, but we're going to transpose the first term and the third term to the right hand side, and that's going to give us negative ax minus c. So what we have here is by equals to negative ax minus c. Now let's divide throughout with b. So y is going to be equals to negative a divided by b times x minus c over b. So here we have successfully converted the general form of the equation ax plus by plus c equals to 0 of the line into a different form, which is also referred to as the slope-intercept form. This is referred to as the slope-intercept form, and the slope-intercept form is usually given by y equals to m times x plus c. So here m, so that represents the slope of the line, and c gives us the y-intercept of the line. So what we need here is the slope. So here, if we compare it with the slope-intercept form of the line, so we have the slope m denoted by m. So that's going to be equals to negative a over b. Okay, so let's label this as number 2. So when we initially considered the coordinate system, we suppose that the coordinate system is has the origin at O. Now let us suppose that we are going to translate the x's such that the origin shifts to a new origin. So O, the origin O, let's call it the origin. Let the origin O shifts to a new origin, O prime, such that means the x's are also going to change, such that we can say x is going to change to x plus h and y changes to y plus k. In other words, what we are saying here, that the origin changes from 0, 0 to a new origin with coordinates h, k. So we can say the origin initially, which was 0, 0, let's say it has moved to a new origin O prime with coordinates h, k. Then the x and the y coordinates are also going to change. So x is going to change as x plus h and y is going to change as y plus k, where x and y in uppercase, this is going to be the coordinates of the new coordinate system with origin at O prime. That in that case, what is going to happen to the equation? So equation 1, we had ax plus by plus c equals to 0. That was the equation of the line originally. Now that we have shifted the origin to a new position O prime, we need to change the x values as well. So let's change the x to x plus h and the corresponding y to y plus k plus c. That's going to be equals to 0. So this is going to give us a times x plus a times h plus b times y plus b times k plus c equals to 0. Now here, what we have is a times x plus b times y. Now a times h, b times k, and plus c, these are all constant. So we can write them together as ah plus b times k plus c equals to 0. So what we'll do now, we're going to keep b times y on the left hand side, and then we're going to transpose ax to the right hand side and also the constant to the right hand side. So we have negative times ah plus bk plus c. Okay, so finally we divide each terms with b such that y becomes equals to negative a over b times x minus, we have a over b times h plus k plus c over b. Now this is the equation of the line in the new coordinate system. So here, if we compare it with y equals to m times x plus c, so comparing the equation, the new equation that we got with y equals to mx plus c, what do we get here? So we get the slope, the new slope, let's call it m prime. The new slope m prime, that comes out to be negative a over b. Now we have gotten the same value here. Earlier also we got this slope to be equals to negative a over b. Now we can say here that as m equals to m prime, and both are giving us the value negative a over b, We can say that the slope of a line is invariant under the translation of x's. Thus, the slope of a line is invariant under the translation of x's. The translation of x's. Hence proved.